So if you didn't finish, that's okay. I know 5 minutes is not too much time, but I do want to keep lecturing. All right. So here's the solution to the first one. Okay, so here, let me just actually do this. There we go. Okay, so again, you can see that I'm using the grid method. So for this polynomial, each term, right? I'm making a column, as you can see. For the other one here, each term, I'm making a row. Again, you could switch it. I just personally like to have more columns than rows. So if you use this polynomial for columns, that's fine. You would have a term for each column, and then each of these would give you a row. Same idea. And then again, to get the grid entries here, all we're doing is we're multiplying. Okay, I will post the lecture notes. I posted something. It doesn't have the examples with their solutions, but I will post the filled in lecture notes as soon as I can. And of course, I'll post the lectures on YouTube. So anyway, again, I'm just multiplying, right? So for the grid entries here, we're multiplying corresponding row and column, right? Like so. And again, we add the exponents. Over here, x cubed times 4x, as you can see, right? That's where the 4x to the fourth comes in. And so on over here, 3 times x cubed. Over here again, we're adding exponents. For this one again, you multiply corresponding row and column terms. So we have 5x squared times 4x, right? 5 times 4, that's where the 20 comes from. X squared times x, that's where the x cubed comes from, and so on. And then again, notice we do have like terms on these diagonals, okay? As you can see. So again, when we add them up, we're going to combine those. I wrote out all the terms, as you can see. And I think I wrote something twice, it looks like. Yeah, I made a mistake. I wrote, here, let me just fix that quickly. Looks like this thing I wrote twice by mistake. Sorry about that. Okay, so again, here's what we're doing. We are writing out the terms. We combine like terms, and this is what we get. All right.
I have a question.
Okay.
When we put the final answer, do we have to show like all the work, like x2 plus 4x plus 3 times x3 plus 5x2 like equals and all that, or can we just put like the final answer?
You mean like show these calculations here?
No, the step on the bottom. Yeah,
Oh,
right there.
Once you get the grid here and then you write your final answer, that's fine.
Okay.
I mean, you could skip this step if that's what you mean.
Yeah.
Okay, you could skip that. But you definitely should write your final answer somewhere. So.
Yeah, okay.
Okay, awesome question. Any other questions? Okay, so that's the first one. Okay, so that's good. Let's move on to the second one. The second one, again, same idea. Well, it's similar, that is. Namely, we have two polynomials, and we're multiplying them. From this one, we get a column for each term, right? That's what I'm using. From here, each term gives us a row. Make sure you include these negative signs. And what do you do next? You multiply to get these grid entries, right? When you multiply, you add the exponents, like so, as you can see, multiplying, and so on. Make sure also, again, you're adding exponents. I know I say that a lot, but I've seen students in the past, they would multiply exponents together. So over here, they would have negative x to the 8th instead of negative x to the 6th. But remember, you add the exponents. And now it looks like the only like terms we have are on this diagonal, right? And again, you could write out all the terms here, but if you see the like terms, it will save a little bit of time because you can add these and get, negative 16x to the fourth. So that's the answer there. Again, I will post the lecture notes here, later on. And one more example. Okay, same idea, right? Right, so here the one with more terms, right? Each term gets a column, gives you a column. Each term from the other polynomial gives you a row, right? And this is what we're doing. So we'll just, right, we multiply corresponding row and column terms to get the grid entries, like so. Like so, okay? This is what we're doing here, okay? And good. And again, to get the final product, you add up these grid entries. The entries in these grids you add up together, as you can see. Good. And again, it looks like, again, the only like terms we have on this diagonal. You're not always going to have like terms, but, sometimes you can. So, okay, so I think that's it for multiplication. All right. Oh, boy. Can't see the mouse. There we go. Okay. All right, so let me stop sharing this. And now what I'm going to do is I'm going to stop recording.